This video will cover how we handle division in complex numbers. But before we get into that, we need to introduce a vocab word called a conjugates. So the conjugate of a number, of a complex number, basically means in your a plus bi, the plus or minus sign in between the two terms is going to get changed. So if it was a plus, it becomes a minus. If it was a minus, it becomes a plus. The reason a conjugate is actually useful is because if you multiply a complex number with its conjugate, the i's will end up canceling, so you'll get just a real number answer. I want to practice finding the conjugate here, and then I'm going to do just one problem with my division using a conjugate. So all I'm going to do here is take whatever sign's in the middle between the a and the bi and just change it. So the conjugate of negative 4 plus 10i is negative 4 minus 10i. I left my negative here. Don't touch these two. Just change the sign in the middle. If I have 5 minus 7i, the conjugate is 5 plus 7i. Left the signs the same here. Just change this. Negative 3 minus 6i is going to become negative 3 plus 6i. Now I actually won't show this here, but if you multiply the black line against the brown line and you do FOIL on those two, or these two, or these two, the i's will end up canceling in your answer, and all you will be left with is just a real number answer. So we don't have an actual process for division. We don't do a division bar like you would have learned back with regular numbers. All we do when we divide or simplify complex numbers here, where we have stuff in our denominator, when it says simplify these, we basically mean we want no i's in the denominator. So leaving i's, imaginary numbers, in your denominator is considered a bad thing. And lucky for us, we learned that a way you can actually get rid of i's is by multiplying by the conjugates. So this red note right here is basically what we're going to do. We're just going to look at the bottom and multiply by the conjugate of whatever's in the bottom. So down there, I have negative 2 plus 3i. I'm going to do negative 2 minus 3i, because when I multiply these two things, my i's are going to go away. That's what I told you in the last on the last slide. However, we can't just multiply the bottom of a fraction by something. If we do it to the bottom, we have to do the exact same thing to the top. So I put that up top as well. I only have one problem in this video because it's a little tedious. You do have to go and do FOIL twice, but you just multiply this out now and let's see what happens. I'm actually going to do my bottom first, just to show you guys when you multiply by the conjugate, it ends up canceling. I'll do that off to the side here. I'm going to get 4, then I'll get plus 6i, then minus 6i, and then minus 9i squared. Just doing my work off to the side here. My i's are going to cancel. I squared is really a negative 1, so negative 9 times negative 1 makes a positive 9. That whole bottom just turns out to be a 13. Again, when you multiply by the conjugates, the i's went away on the bottom. Now I just multiply my tops. I'll do that off to the side over here. 4 minus 5i times negative 2 minus 3i. I get negative 8 minus 12i plus 10i. Kind of speeding through this here. And when I do a little bit of simplification on my bottom, this is going to turn into a minus 15. I'm going to get negative 23 minus 2i. There's an I on the top still, but that's okay. When you do these problems, the important thing is that there's no more i's in your denominator. So this would be a good answer, and actually what you'll often see people do when they divide complex numbers, they'll go one step further and split it into two separate fractions. So they'll put these two in a fraction and these two. So that would look like negative 23 over 13 minus 2 over 13, and they'll usually put the I out like this. So now it's actually an a plus bi form. So take the original fraction, multiply top and bottom by the conjugate of the denominator, and do a little bit of math. You get your answer. We're not going to emphasize division a lot, but I wanted to show it at least so you've seen it done.